Welcome to another edition of Common Algebra. This video is for Algebra 2, Chapter 6, Section 5. It's really Part 1 of dividing with polynomials. Part 1 will cover what we call long division, and Part 2, the other part of this, is called synthetic division, so that's a separate video. So the first thing we're going to divide is a long polynomial by a single term, a monomial. And when you have this, you're just dividing this part into each term separately. So you're kind of treating it like three separate problems. Some people might even prefer to write it out as three separate problems. So I wrote this out as the three terms, each being divided by the 3xy. And whether you write it out this way or not, this is what you're thinking. So when we check, 8 doesn't divide by 3 evenly, so you can leave that as 8/3. And then you got to remember your exponents. X to the third divided by x is x squared, and y divided by y is 1, so that the y's cancel. Now let's look at the next term. 3 divided by 3 is 1, so that's gone. X squared divided by x is x. Y squared divided by y is y. So all that's left of this middle part is xy. And here, negative 12 divided by 3 is negative 4. The x's cancel, and we're left with a y squared. And then I'm checking to see if any of these are like terms that could be added. They are not like terms, so that's our final answer. So now let's go over long division. As we talk about these steps, I'm going to set it up here with this example because I think that would be the most clear way to explain it. So before we can even do step 1, we have to set this up for long division. So let's put this number, which is what we're using as the divisor. We're dividing 4y minus 1 into this polynomial. 16y squared plus 4y minus 2. So now we have to pick a multiplier to write up here that gives us an exact match to the first term. So I'm trying to figure out what I would multiply times 4y to get exactly 16y squared. In this type of long division, the first term has to add to 0. So that's why we're trying to match it. And we know that 4 times 4 is 16, and y times y is y squared. So that would be my perfect match. And now that's picking the multiplier to give an exact match. Now we're supposed to distribute the multiplier. So I'm going to draw in the arrows what I mean by distribute. You're going to multiply that 4y times 4y, and then we're going to multiply the 4y times the negative 1. So if I multiply that, I get 16y squared minus 4y. Now I'm going to draw a line here. So I always check, this has to be a perfect match. Now really, in the old days, you subtracted this, but I have learned instead of putting step 3 as the word subtract, I'm writing change the signs and add. So that really is subtracting. This is a positive, so I'm going to change this to a negative. This negative 4y is going to get changed to a positive. So really we are subtracting, and it's really the same as distributing the subtract sign. So now let's go ahead, change the signs, and now we add. This has to add to 0, or I haven't accomplished anything in this long division. So that's good that that happened. 4y plus 4y is 8y. And now step 4 says bring down the next term. So I bring down this minus 2, and we start all over again. So now we're picking a multiplier that's going to be an exact match. What times 4y is exactly 8y, and we know that that would be a plus 2. So again, distribute. I'll draw in these arrows. 2 times 4y is 8y. Again, has to be a perfect match. 2 times negative 1 is negative 2. So now let's do this step where we change the signs and add. So change that positive to a negative, change that negative to a positive, and then we add straight down. Oh, and this time the remainder is 0. So the answer when we divide here is just 4y plus 2. In this example, we are asked to determine if this factor, if x minus 2, if it is indeed a factor of this polynomial. And my little note here says, if the remainder is 0, then we will say yes, it's a factor. If it's anything else, we'll have to say no. So let's set up our long division here. We have x minus 2 outside the bridge and this polynomial under the bridge. Now, as I'm writing this down, I'm noticing something. I'm looking at the descending powers. We have a third power, a squared power, and you'll notice that the x term is missing. So we're going to have a placeholder in there. We're going to have to write a 0x for that missing x term. Otherwise, our process of dividing is going to get messed up. So once again, we want a perfect match. What could we multiply here times x to give us exactly 3x to the third? Well, we're going to need the 3, and we're going to need an x squared. And now we distribute this. So 3x squared times x is 3x cubed. 3x squared times a negative 2 is a negative 6x squared. The next step is change the signs and add. Again, this has to go to 0 or you've accomplished nothing, and then go back and adjust your multiplier. Adding straight down, we get a negative 2x squared. Bring down the next term, get a perfect match. I would need a minus 2x to get a perfect match. Now distribute that. Negative 2x times x is negative 2x squared, and that would be negative times negative is a positive 4x. Once again, change the signs and add. This added to 0, I always check that. This is a negative 4x. Bring down the next term and ask yourself again, what could my multiplier be that will give me a perfect match? What do I multiply x by to get a negative 4x? I would need a negative 4. Distribute this negative 4 to both terms here. So I get a negative 4x, and this would be plus 8. Change the signs and add. And I'm noticing that I do have a remainder of 6. So this is the answer when we divide this factor into this polynomial. We get 3x squared minus 2x minus 4, remainder 6. So because there's a remainder, we're going to say, no, this is not a factor. Okay, so now you should have the knowledge you need to do the long division part of section 6.5. So have fun with math.